This is a view of the oblique fracture of the humerus. Place the proximal fragment in the vise and reduce the fracture using the large pointed reduction forceps. With the 3.5 mm drill bit through the double drill sleeve, drill the glide hole perpendicular to the fracture line in the near cortex. Insert the 2.5 mm end of the double drill sleeve through the glide hole until it engages the far cortex. Use the 2.5 mm drill bit to create the thread hole in the far cortex. The countersink is used to increase the bone screw head contact. Determine the screw length with the depth gauge. Place the 3.5 mm tap through the double drill sleeve and cut the thread in the far cortex. Insert the 3.5 mm cortex screw. This provides compression along the fracture line. Adjust the bone in the vise so that the medial side is uppermost. Contour the bending template to the medial side of the bone. The bending pliers are used to contour the plate to the shape of the bone. The medium-sized anvil is inserted into the bending pliers and secured in place. The bending bar has a convex surface, a flat surface, and a concave surface. The convex surface is used on the concave side of the plate. The position of the handles is adjusted by turning the knob at the end of the pliers. The bending template is used to indicate where the plate needs to be bent to match the shape of the bone. The plate is bent along its length at multiple sites between the plate holes until its shape matches that of the bending template. The plate is secured to the medial side of the humerus with the reduction forceps. The green neutral drill guide is centered in the plate hole at one end of the plate, and a 2.5 mm hole is drilled through both cortices. The depth gauge is used to determine the length of the screw. The 3.5 mm tap through the double drill sleeve is used to cut the thread in both cortices. Insert the 3.5 mm cortex screw. A second screw is inserted in the same manner at the other end of the plate. The rest of the screws are inserted on either side of the fracture, repeating the same sequence of drilling, measuring, tapping, and inserting the screw. The reduction forceps are removed, and each screw is retightened. The fracture has been anatomically reduced and stabilized with a lag screw. The plate protects the fracture reduction and has a neutralization function.